video, we're going to look at trigonometry, a brand new concept. Now, trigonometry, trig means triangles, and metry means to measure. So we are going to be measuring triangles. But before we get into too much detail, we need to look at how we can name the sides of a triangle, because this is very, very important in trigonometry. So if I have a triangle ABC, my side opposite my right angle is always called the hypotenuse, but we know this. Then, if I'm given an angle in the triangle, the side opposite that given angle is known as the opposite side. And the remaining side, or the side next to the given angle, is known as the adjacent side. So let's just look at one or two more triangles to get their labels sorted out. So if we have a look at another one, the side opposite that right angle is going to be called the hypotenuse. And in this case, we want to look at 35 degrees, so we want to look at angle B. So the side opposite that angle B is going to be called the opposite side, and the remaining side is called the adjacent side. Let's just look at one more. Right, in this triangle, again, my hypotenuse is the easiest to identify. It's opposite my right angle. Then if I want to look at angle C, which is 20 degrees, the side opposite that, in other words AB, will be known as the opposite side, and the remaining side is adjacent. Okay, so we need to just keep that in mind, and we're going to come back to that in a little while. Let's have a look at these four triangles. Now, hopefully you notice with these four triangles, they are similar triangles. They're all exactly the same in terms of their angles. Okay, I haven't said how big the angles are, but all those angles are exactly the same size. And using Pythagoras, I would like you to calculate the length of each hypotenuse. And I'm going to do the first one with you. So I will do triangle A with you. And if I want to calculate the hypotenuse, I take the sum of the squares of the other two sides. So 6 squared plus 8 squared will give me the hypotenuse squared. So 6 squared is 36 and 8 squared is 64. So 36 plus 64 is 100. So in other words, the hypotenuse will be the square root of 100, which is 10. And if you use the same method on all three other triangles, you should find that the hypotenuse on triangle B is 15, on triangle C is 20, and on triangle D is 5. Okay, now I just want to stress again that these are all similar triangles. What does that mean? That the angles are exactly the same size. The sides are not necessarily, but the angles are exactly the same size. Now, if I had to ask you to calculate the opposite side over the hypotenuse for each triangle, something very interesting happens, and it is because the angles are the same size. Okay, so if I ask you for angle A, triangle A, to calculate the opposite over the hypotenuse, we are going to end up with 6 over 10. Remember, angle X is the angle I'm working with, so 6 will be opposite angle X, and 10 is opposite my right angle. So 6 over 10, which I can simplify to 3 over 5. If we have a look in triangle B, if I'm working with angle X, the opposite side will be 9 and the hypotenuse will be 15, which I can simplify to 3 over 5. In triangle C, if I ask you to calculate the opposite side over the hypotenuse, because we're working with angle X, the opposite side will be 12 and the hypotenuse will be 20, and that also simplifies to 3 over 5. And the last triangle, opposite over hypotenuse, will also give you 3 over 5. So what I notice is every time I calculate the opposite side over the hypotenuse, I get exactly the same fraction. And the reason for that is the triangles have exactly the same angles. Okay. Now in a test or exam, it seems quite pointless for me to ask you for the opposite side over the hypotenuse every time, or the adjacent side over the hypotenuse. So all we do is we've given these relationships special names. And this is the big introduction to trig. So if I want you to work out the opposite side over the hypotenuse, instead of me asking for opposite over hypotenuse, I will just ask you for the sine of angle A. which we can then abbreviate to O over H. If I wanted you to work out the adjacent side over the hypotenuse, I would ask you to work out cosine of A or cos A. And if I wanted you to work out the opposite side over the adjacent side, I would ask you to work out tangent of A, or abbreviated to tan A. So sine, cos, and tan are just abbreviations for specific relationships. And we're going to use this little rhyme, SOHCAHTOA, to remember. So sine is always the opposite side over the hypotenuse. Cos is always the adjacent side over the hypotenuse. And tan is always opposite over adjacent. So all you need to understand here is, instead of me saying take the opposite side and divide it by the adjacent side, I can ask you calculate tan. So it's just a very specific name given to a specific fraction. So let's have a look at a possible question. In this triangle ABC, I would like us to think about sine, cos, and tan in this specific triangle. Now, if I ask you to write down the sine of C, sine, if you look at SOHCAHTOA, is OH. So it's going to be the opposite side over the hypotenuse. Now, if we're working with angle C, our hypotenuse is easy to figure out because it's opposite the right angle. Then AB will be the opposite side because it's opposite the angle that I've asked you. I've asked you for sine C, so we look at the side opposite C, which means BC is the remaining side, so it's adjacent. So if I ask you for the sine of C, it'll just be the opposite side, which is AB, over the hypotenuse, which is AC. So instead of me asking what is opposite over hypotenuse, I'll just ask you for sine instead. With the next one, I want us to work out the cos of angle C, or write down the ratio of cos C. So we're working with angle C, so our labels stay exactly the same. And if we look at SOHCAHTOA at the bottom of the screen, cos is AH. So it means it's the adjacent side over the hypotenuse. The letter that's listed first is always the numerator. The letter that's listed second is always the denominator. So in my drawing, which side is the adjacent side? My adjacent side is BC, and my hypotenuse is AC. Last one, tan C. All right, so again, I'm asking you tan of angle C, so my labels stay exactly the same. And according to SOHCAHTOA, tan is opposite over adjacent. So I want you to write down the opposite side divided by the adjacent side. So the opposite side is AB, and the adjacent side is BC. Let's flip it around. And now let's find the same things, but we're going to use a different angle. Now we're going to use angle A. Now if we ask you to use a different angle, all your labels must change. So your hypotenuse is still going to stay the same. Your hypotenuse is always going to be opposite your right angle. The opposite side to angle A is now BC, and the adjacent side is now AB. So your labels, your names depend completely on which angle we are working with. So according to SOHCAHTOA, sine is opposite over hypotenuse. So the opposite side is now BC, and the hypotenuse is AC. If I ask you to work out the cos of A, cos according to SOHCAHTOA is adjacent over hypotenuse, and the adjacent side in my drawing is AB, and the hypotenuse is AC. And tan in my drawing, tan of A, tan is opposite adjacent, so it's going to be the opposite side over the adjacent side, so BC over AB. Let's try one more that I have seen asked in a previous exam. Give you a triangle and you're asked to state the following in terms of M, P, and T. And they've given you a little triangle, they've labeled the sides for you. And we are going to work with that little angle. We call it theta. I'll come back to that in a minute. The angle opposite my right angle is the hypotenuse. The side opposite the angle I want to work with is known as my opposite side. And next to is my adjacent side. and I want you to work out sine theta. Now that little symbol is a circle with a line through it, and it's actually one of the Greek letters. And in trigonometry, we tend to use quite a few of the Greek letters instead of just normally X and Y and A and B. We tend to use Greek letters, and this is just the first one. So it's nothing different, it's just a symbol to indicate the size of an angle. So if I want you to work out sine theta, remember sine is opposite over hypotenuse, O over H. So the opposite side is T, and the adjacent, the hypotenuse is M. So opposite over hypotenuse will just be T over M. If I ask you to work out tan theta, if I look at SOHCAHTOA, tan is opposite adjacent. So it means it's the opposite side over the adjacent side. So it will be T over P. And finally, if I ask you cos theta, according to SOHCAHTOA, cos is adjacent over hypotenuse. So the adjacent side is P, and the hypotenuse is M. So it's just P over M. And that's how they could ask it in an exam. Thanks for watching Max Maths. If you liked what you saw, please like, share, and subscribe.